Alright, in this example here, we have a system of equations that we're going to try to find a solution for by graphing. By solving this by using the graphing method, we want to graph both lines and look for their intersection. And that intersection will tell us that that solution satisfies both equations. So I'm going to work with this first equation that I have here in red, the 3x plus y equals 9. I want to graph that. So to graph it, I need to know a couple of things about this line. And I know it's in standard form. So knowing that it's in standard form, I can find the y-intercept, and I can find the slope, and I can even find the x-intercept if I need to. And I know, being that it's in standard form, I know that the y-intercept is going to be c over b, because standard form is ax plus by equals c, and I know that the y-intercept is going to be the value of c over b, and in this case that would be my c is 9 and my b is 1, so 9 over 1, or just 9. So I have a y-intercept of 9, so I can put a point on my y-axis at 9. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So I have my y-intercept here at 9. And then I know my slope is a negative a over b. If I have a slope that's a negative a over b, well, that tells me I have a slope that equals negative 3 over 1, or just negative 3. So a slope of negative 3 tells me to go down 3 and right 1 to get a negative slope. And then down 3 and over 1. And now I have a line, so I can just connect these dots. Line. And draw my line here. Usually helpful to have a nice straight edge, but if not, it doesn't have to be a perfect line, because we're just trying to estimate our value where they intersect. Okay, so there's my line in red. Okay, now I'm going to try to do the line in black. So again, that's in standard form. The 2x plus 3y equals 13. So I'm going to try to graph this one as well. Okay, and on this one, I can do it the same way. It's in standard form. I can find my y-intercept as 13 over 3. And 13 over 3, my y-intercept, is going to get us 4 and 1/3. Okay, so my y-intercept, I'm going to go up 1, 2, 3, 4 and 1/3. So I'm crossing the y-axis right about here. 4 and 1/3. Okay. And I know that my slope is going to be a negative a, or negative 2, over b, which is 3. So I have a negative 2/3. Okay, and that's my slope. And my x-intercept, because I think that's going to be a little more helpful here, being that I have a value that's 1/3, my x-intercept is c over a, which we should all remember in standard form, and that's going to equal 13 over 2, and that's my x-intercept. So if I move my slope here, just move my slope. Doesn't want to cooperate with me today, but I can try to move it without moving it. There we go. Let's label this x-intercept, in case you don't remember it from the last video. But our x-intercept is 13 over 2, or 6.5. That's my x-intercept. So if I plot that on my graph, so 1, 2, 3, 4, 5, 6.5, is right about here. And if I draw that line, again, I can use my slope as well and see that if I go down, negative 2/3 tells me to go down 2, so down 1, 2, and over 1, 2, 3, I'd have a point right here. You can see if I just connect all three of those using my straight edge. Alright, there's that line. And you can see that these two lines do in fact intersect, and they appear to intersect right here at this location. And the coordinate of that intersection I can see is the value 2, 3. Okay, so we graphed both lines. But the great thing about this is I can check my answer. In both equations here, is 2, 3 a solution? So again, I can check both of those. So let's add some space to our paper here. My first equation again, is 3x plus y equals 9. I'm going to check both of these. 3x plus y equals 9. And my second equation is 2x plus 3y equals 13. And again, we're checking to see if the ordered pair 2, 3 is a solution for both. So I'm just going to substitute 2, 3 into both equations. So I have 3 times 2 plus plus 3 equals 9. And 3 times 2 is 6 plus 3. And that does in fact equal 9. So it is a solution here, yes. And here, same thing. I'm going to take my 2, 3 that we got. We're going to substitute that into this one here. So I have my 2 times 2 plus 3 times 3. And does that equal 13? And yes, 2 times 2 is 4 plus 9. And does that equal 13? It sure does. 13 equals 13. So it satisfies both. So it is a solution. And it's pretty quick. You saw how quickly it was to intersect or find the intersection of these two lines just by graphing them. We can use a lot of different graphing calculators or online graphers that would have helped to verify that as well. And we could find our solution just by finding their intersection.